Okay, good afternoon, each and everyone. This is Vipul once again. Today we are supposed to deal with 3-4 different sessions, but it's fine. It's okay. I will make sure that you guys will not that much. You will not feel that much heavy. Okay. So we'll present my content accordingly. Don't worry. So this was the slide we were dealing with, and yes, it's visible. Is it now? It's properly visible. Okay. Yes, please. Come in, come in, come in, come in. Quickly, take your seat. Yes, guys. So we had gone through first two observations related to adjacency matrix. Now, if we go for the third one, if graph has no shelf loop, the degree of vertex is equals to number of ones, number of entries of one in the corresponding rows of a column, rows or column of that particular vertex. Now, observe here. Suppose this is a graph. This is the actual graph, and this is respective adjacency matrix. Now, if we wish to check whether that particular third observation is correct or not, let's pick one of the vertex randomly. Let's pick V3. Now, you can clearly observe that the degree of vertex V3 is 4. Is it? Degree of vertex V3 is 4. 4 different edges are connected with vertex V3. Now, if we observe the row related to vertex V3, then surely we will have 4 entries of 1, first, second, third, and 4. Similarly, if you observe the column related to V3, then surely that column will have 4 entries of 1. Is it? That is what the observation third is. It is quite simple, quite obvious thing. And this is very, very interesting. The last observation, if we are dealing with one of the graph which is disconnected graph, if we are dealing with one of the disconnected graph, that means might be that particular graph is having two different component with them, two different components, दोनों अलग ही है, दोनों के बीच में कोई connection नहीं है, a disconnected graph. Then the adjacency matrix related to such disconnected graph will look like this. Surely we will have one of the kind of submatrix over there and kind of submatrix in the lower left hand corner, lower right hand corner. Sorry, my mistake. That's it. कैसे? चलिए दिखाता हूँ. Let's try to understand this with the help of one of the disconnected graphs. Suppose I'm having a graph with 4 vertices. Let me label the vertices A, B, C, D, and E and F. E as F. Okay. Now let me make a disconnected graph. Let me add one more edge over there. Suppose this is a graph. This is a graph. This is graph G. Now clearly you can observe that this is disconnected graph, is it? We are not having connection between both this component. This is first component, this is second component of graph. So this graph is having two different components. So this is disconnected. Now, if we try to identify, if we try to trace its adjacency matrix, then first of all, we need to decide the order of that particular matrix. Now, how we are deciding the order of that adjacency matrix? Using its number of vertices, is it? The number of vertices I had included in the graph G is 6. So surely the adjacency matrix related to this particular graph will be of the order 6 cross 6. 6 cross 6, is it? And what we are supposed to do? We need to label my vertices in the row as well as column. A, B, C, D, E, F, as well as A, B, C, D, E, F. Is it? These are the different vertices. Now, to identify its adjacency matrix, we just need to check how many connections does that particular vertex A is having. For this particular first row entry, A is having connection with B, C, as well as D. So B, C, as well as D, these 3 entries will be 1, and rest of 3 entries will be 0. Similarly, let's go for vertex B. B is connected with A and C only. B is connected with A and C only, and rest of all the entries will be 0. Observe this. Similarly, if we go for the C, then C is having connection with A, B, and D, A, B, as well as D, and rest of all the entries will be 0. And let's move for D. D is connected with A as well as C. So A यहाँ पे 1 आएगा, यहाँ पे 1 आएगा, and rest of all the entries will be 0. Now, moving for the next component, that is E. In the next component, we are having two different vertices, that is E and F. Let's go for E. E is having only connection with F. So this will be 1, and rest of the entries will be 0. And for F, the entry will be for E only, and rest of entries will be 0. Now, what I was saying, just observe this. Let me change the color of my ink. Observe this component. This as well as this. Now, if you can identify them, this component, this particular component is literally for this one. This particular part of matrix is literally for this particular component. And for this component, this is a kind of submatrix over there. That's it. So that is what I had mentioned in the previous slide. Last observation is something like that. A graph is disconnected. If a graph is disconnected graph, and if it has two components G and F, then its adjacency matrix A can be partitioned as adjacency related to G will be on the upper left hand corner, and adjacency related to F might be on the lower left hand corner. That may vary. यहाँ पे F हो सकता है, यहाँ पे G हो सकता है. That depends on the order of the vertices which we are using. And always take care here. Order of this particular vertex is not important. Order of this particular vertices is not important. It is not like that. Okay, always will be following this order V1, V2, V3, V4, V5. But what we need to take care, the order which we are following on the row, the same order we will follow for the columns. Okay. Okay, but we cannot change over here. Okay, यहाँ पे मैं लिख रहा हूँ V1, V2, V3, V4, V5, and I'm writing in the descending order over here V5, V4, V3. ये थोड़ा गड़बड़ हो जाएगा, ठीक है? So this is related to adjacency matrix. Now these are some of the examples. Adjacency matrix of this particular graph. Now observe, in this graph I had included self loop over A, as well as self loop is there for the vertex B. Is it? Now, if you observe that self loop is reflected over here, I need to change the color once again. Yes, that self loop is reflected over here. This self loop is for this entry is 1 for this. This one represents that B is having connection with B. What I need to do, I need to label the column and rows A, B, C, D, then and then you will be able to understand this. So this one reflects that B is having connection with B. Is it? What is this? This is actually this particular self loop. Yes, one of the question from the separate vertices, yes. No. In that particular case, it will be nothing. Okay. Good. Let me take you further. Can you give me the adjacency matrix for this particular graph? Quickly, all those who are present in front of me, as well as all those who are attending this meeting online, you are supposed to give me adjacency matrix of this graph quickly. Right now, I'm giving you 2 minutes. Quickly, give me the adjacency matrix of this graph quickly. Yeah. You're supposed to give me the adjacency matrix related to this graph. The level of vertices are A, B, C, D, E, F. 6 vertices are there. We don't need to label, we don't actually need to label that edges, okay? It's okay if you're not using that notation related to edges. चलो जल्दी जल्दी जब की बार नहीं लगे ड्रॉ कर ले जल्दी ग्राफ हूँ स्क्रीन पर लाविश बेंजीन અને 3 हाँ हाँ डन गौदीप का हो चुका है ठीक है It will be something like this, is it? अधिक चेक कर देख तो सही है तेरा तो सही होगा मेरा चेक करके देख ले ये सही है कि नहीं है Bhavdeep, am I audible? Is it? Good. So all those who are in front of me are not facing any kind of issue related to this, is it? These are some of the different examples even. This is K5, is it? 4 regular graph. Is it? This is 4 regular graph. No. We are not going to identify this, but just observe some of the things. Just observe. How many number of ones are there in the first row? 4. And similarly, we are having 4 ones in the first column, is it? What it reflects? It reflects the degree of vertex A. It reflects degree of vertex A. Similarly, in the second row, we will have 4 ones. And in the second column, we will have 4 ones. So this is what about the adjacency matrix. Hopefully, you guys are good with this now. इसमें ज़्यादा example करने से कोई फायदा नहीं होगा. You guys are good, but let me give you one more. If you are having a self loop, क्योंकि self loop वाला हमने इससे पहले भी एक example include कर लिया, पर फिर भी एक बार देख ले. Observe here. For the vertex V, we are having self loop. Is it? So if I'm gonna label my vertices like this, suppose this is a vertex, this is a row which is connected with vertex D, then I must have one over there. Similarly, for E, for vertex E, I'm having entry 1 because I'm having self loop for vertex E also. Self loop. Graph majo. This is self loop for A. This is self loop for B. Okay. Goga to taru koi dhyan જ નથી એમ ને lecture. Let me move further. Good with this. Now, let's apply this logic in reverse way. Now, what I am doing, I'm giving you one of the matrix. You need to give me the graph. You guys will draw a graph related to that adjacency matrix. Now, take care. Listen to me carefully. When someone is providing you matrix, there must be clear-cut information whether that matrix is adjacency matrix or incidence matrix. We are going to learn 2-3 different types of matrix from the graph. So it will be clearly mentioned in the question that this is adjacency matrix and you are supposed to give me a graph. This is incidence matrix and you are supposed to give me the respective graph. Is it? So what I am doing, I am giving you adjacency matrix. This is one of the adjacency matrix. Now take care, I had not labeled my vertices. You can clearly observe this is 4 cross 4 matrix, is it? That means you are supposed to use 4 vertices. Now that notation, whether you are using V1, V2, V3, V4 as your vertices or whether you are using A, B, C, D as your vertices, that is up to you. You may decide that. Okay? I'm giving you 2 minutes quickly. You're supposed to give me the graph related to this adjacency matrix. All those who are attending online, are we good with this? Are we good with this? क्या बोलने को क्या करने को बोला है पता है ना? हाँ ठीक है, good. Let me show you we are learning how we are learning this. Let me show you by on. Let me on my webcam. This is what I had arranged in the classroom. This is the podium, is it? Podium of our class. This is my system. I'm using this particular digital pad, and what I'm doing when I'm writing something over there, which is reflected on the screen. Suppose I'm writing over here as a pen. It will be reflected on the screen, is it? And this is the way I'm presenting in front of all the offline students. Observe, this is a projector. We are taking help of projector. I'm not using my whiteboard. Okay, these are some of the students. Those are present over here. Yes, good. So let me show. Now match this particular graph with yours. Is it? Now it is not like that कि your presentation must be like this. ऐसा नहीं है कि ऐसे ही present करना है. Your design, आपने जो structure बनाया है उससे कुछ अलग भी हो सकता है, is it? And you may use any of the labeling with the vertices. Okay, don't worry about that. Let's try one more. Let's try one more. Now I'm giving you the label of the vertices. This is your adjacency matrix. Quickly give me a graph related to this. अब मैंने vertices fix कर दिए, देखिए ABCDEF only. Meghna, are you done? Pranjul, Aditya, Bharti. Prema, Saif Ali, Shushil, Smriti Chudasma. One of our D2D. Smriti, am I audible to you, dear? Smriti. कनेक्शन नहीं चला गया ना. Hello, am I audible to you, all those who are attending this online?
Yes, sir.
Good. Is it? So this will be the kind of graph. Is it? देखिए सही है. हाँ, तो it's fine. If this is a matrix, let's move for the next one. Let's move for the next one. Now we are good. We are not gonna draw that. This will be the kind of graph related to the third example. In the third example, observe that I provided one of the entry 1 over there, which indicates that D will have self loop over here, over itself. Is it? Here it is a self loop. Is it? So that was a story related to adjacency matrix. Now let's understand what we mean by incidence matrix. Incidence matrix. Now can you define this? Will you try? Adjacency में हम क्या बात कर रहे थे? We were labeling or the row and column we were using vertices, is it? Now in the incidence matrix, what we will be using. I'm waiting for your answer over the chat box. In the case of incidence matrix, what we will be using to label row and columns of that matrix? Edges, is it? No? Yes. Let G be the graph with m vertices and n number of edges. M vertices and edges. And yet, first of all, I'm restricting self-loop. No self-loop is there. Now, I'm defining matrix A like this, of the size m cross n. That means m means number of row. Now, m means number of vertices. M means number of vertices. So, number of vertices cross number of edges. So, our matrix will be a kind of rectangular array where number of rows will be equals to number of vertices and number of column will equals to number of edges. अब उसमें भी एंट्रीज तो हम दो ही अलाउ करेंगे, 1 और 0 कैसे? Where m rows correspond to m vertices. Who's that? Dhruvi. ये तो वो वाला केस हो गया ना, श्वेता माइक अनम्यूट कर। ध्रुवी म्यूट कर ले अपने आप को। ध्रुवी म्यूट योरसेल्फ। लेट मी म्यूट हर। पता है वो सभी को, कितनों को पता है वो? अभी डिस्कस नहीं हो सकता, रिकॉर्डिंग इज ऑन। ओके, लेट्स कंटिन्यू। बस रिकॉर्डिंग चालू है बच्चों। ठीक है। And now in the incidence matrix, the type of that particular matrix will be m cross n, is it? Where m rows correspond to m vertices and columns correspond to n number of edges. किस तरीके से? अब उसमें एंट्री 1 और 0 कब देंगे? We will allot a specific entry 1 to one of the specific place if I am interacting with aij plus aij. जब भी हम लिख रहे हैं, might be I just forgot in the previous session what we mean by aij. If I'm writing a12, what does it mean? That is an element of first row and second column, is it? If I'm labeling one of my element as a3, 2, तो ये वाली एंट्री a32 नहीं है, ठीक है? a32 नहीं है. We are habituated to read this particular as a3, 2, a32, is it? What does it mean? Entry of third row and second column. Entry which intersects third row and second column. Similar way, when we are using this notation aij, that means we are dealing with ith row and jth column. That intersection of ith row and jth column we will label as 1 if jth edge is incidence to ith vertex. क्यों भाई? रो में हम क्या देने वाले हैं? That will be number of vertices, so ith vertex, and column will leads to number of edges, is it? So अगर I वाली edge, मानी कि if I am using this a23 as a 1, if I am giving 1 over a23 over the place 2, 3, that means second row and third column. That means second row third column मानी कि क्या? इसका मतलब क्या होगा? Second row में कौन सी एंट्री है? Vertices वाली, is it? तो second vertex or third edge अगर incidence है, then we will allot 1 over that respective place. Okay, so we'll be using this tactic, we will be using this logic to generate incidence matrix. Earlier we were constructing adjacency matrix, now we are dealing with the incidence matrix. So अगर वहां पे connection नहीं है, then we will allot 0. Otherwise, in all the other cases, we will allot 0. Is it? Yeah, surely. It will be quite simple if we are dealing with the example. Chobo Selupers example. Consider this as a graph. All those who are having a kind of confusion in the previous definition, if you are having any of the confusion related to previous definition, ये वाले में अगर कहीं पे कोई doubt है, सर ये ith ये कुछ दिमाग में नहीं जा रहा है ठीक से, ith jth edge and ith vertex, I'm not good with this. So it's okay, it's totally fine. You're not supposed to write down this definition anywhere. What we are supposed to do, we are supposed to construct a matrix, incidence matrix. So let's try to construct one of the incidence matrix from this particular graph. Consider this as a graph. Let me label this graph as a G. This is a graph G. Now observe the number of vertices I am having: 1, 2, 3, and 4. 4 vertices over there. So we are having 4 vertex. Cardinality of vertex set is 4. Now count the number of edges over there. Count the number of edges quickly. 6 edges are there. So will you provide me, if I'm going to label my incidence matrix as A, then what will be the type of this matrix? What should be the type of this matrix? Bhavdeep, Meghna, Raj, Tanjul. अरे सो गए क्या सारे के सारे?
Incidence matrix.
Sorry? What will be the type of this matrix? Type क्या होगी इसमें? कितनी रो होगी, कितनी कॉलम होगी? 4 cross 6 या 6 cross 4?
6 cross 6.
6 cross 6. Why you are saying 6 cross 6? Raj, why you are saying 6 cross 6? Now we are dealing with the incidence matrix.
Sorry,
So we need to take care about vertex as well as edges, is it? So this matrix will be of 4 cross 6. Now all 4 rows will be associated with 4 vertices, and all 6 columns will be associated with one of the edges. Are we good with this? Are we good with this? इतना समझ में आ रहा है सभी को? हाँ या ना? हाँ या ना?
Yes, sir.
Yes, sir.
Good. Then let me show the actual graph, actual incidence matrix. Observe this. And let me know how many of you are good with this. अब ठीक से देख के बताओ क्या समझ में आ रहा है? Yes, that's what we are supposed to represent. Which of the edge is connected with which of the vertex, that's all. If you observe that, even both the endpoint of even is A and B, is it? तो even वाली कॉलम देखिए आप, उसमें 2 ही एंट्री होगी, 1 एक A के लिए है, एक B के लिए है. Now observe E2, उसमें एक एंट्री A के लिए, एक C के लिए. E2 के 2 टर्मिनल वर्टाइसेस देखिए. E2 is here. Both the terminal vertices are A and C, is it? And if you observe column wise, if you observe row wise, अगर हम row wise देखें इस मैट्रिक्स को, अगर हम row wise देखें तो देखिए इसका क्या मतलब है? डिग्री ऑफ दिस वर्टेक्स इज 3, और वो किन किन के साथ, कौन कौन सी वर्टेक्स है, जो कौन कौन सी एजेस है जो ए से या तो स्टार्ट हो रही है या तो खत्म हो रही है. वन ऑफ द वर्टेक्स इज E6, E1 एंड E2. तो एंट्री जो E1, E2, E6 में होगी, E1, E2 एंड E6, इज इट? बट मेजर डिफरेंस क्या है दोनों में? एडजेसेंसी मैट्रिक्स, इंसिडेंस मैट्रिक्स. एडजेसेंसी मैट्रिक्स ऑलवेज स्क्वायर होता है. यस. And it is always symmetric. Adjacency matrix जो होता है वो स्क्वायर होता है, वो हमेशा always symmetric होता है. पर when we are dealing with the incidence matrix, we are using both that, edges as well as vertices. So ये rectangular रहेगा ज्यादातर. Is it? Good. कौन सी? H की डिग्री. हाँ, H हो भी सकता है. तू कोई ऐसा ग्राफ बता दे जिसमें 4 वर्टाइसेस 4 एजेस है. Is it? Adjacency matrix, incidence matrix related to this will be surely square matrix. Yes, Raj or one of you. प्रीत कौन बोल रहा था?
सर अगर डायरेक्टेड ग्राफ होगा तो एडजेंस वो मैट्रिक्स वो वाला.
हाँ, उसमें अभी बनाएंगे. रुक जा, डायरेक्टेड ग्राफ के साथ भी डील करेंगे. Don't worry. In that we will be adding one more logic over there. Okay, but wait. Some of the observation. Go for both this quickly. Since every edge is incidence on exactly 2 vertices, each column of adjacency matrix has only 2 1. हमने देखा अभी पिछले एग्जांपल में, हर एक कॉलम में 2 ही बार 1 हो सकता है. देखिए इस कॉलम में 2 ही एंट्री हो सकती है जो 1 है. सेकंड कॉलम में 2 ही बार 1 की एंट्री होगी. will have only 2 ones in the any of the row of that matrix, क्योंकि वो एक age के बारे में बात कर रहे हैं हम. When I'm talking about this particular column, any of the, sorry, what's wrong with this? Why my pad is not working? Yes, now it's working. Yeah. If we talk about any of the column, तो उसमें 2 ही बार एंट्री होगी जो कि 1 है. Is it? कोई भी रो, कोई भी कॉलम ले लीजिए. Is it? That is what I mentioned in the first observation. Now go for the second one. The number of ones in each row is equal to degree of that corresponding vertex. ये भी बहुत ही कॉमन सी बात है. A row with all 0 element represents the isolated vertex. अब ऐसा हुआ नहीं. अब देख लीजिए, शायद यहां पे एक और वर्टेक्स है. सॉरी, let me take you back. अगर इस ग्राफ में एक और वर्टेक्स मैं ऐड कर रहा हूं, सपोज आई एम एडिंग वन मोर टेक्स ABCD एंड आई एम एडिंग E ओवर दैट. सपोज कि यहां पे एक E है, तो जो भी यहां पे जिस इंसिडेंस मैट्रिक्स हमने बनाया उसमें क्या क्या चेंज होगा, कौन बताएगा मुझे? If I am adding one more edge over here in this particular graph, तो इस मैट्रिक्स में चेंज क्या होगा? सिर्फ एक रो चेंज,
एक रो ऐड होगी.
Yes, we need to add one more row over here, and type of this matrix will be 5 cross 6. If I'm not giving any connection to E, that means I'm making this graph disconnected. If I'm not associating E with any of the other vertex, then surely this is disconnected graph, and all the entries related to row E will be 0. Is it? That row will be 0 row. That is what I had mentioned in the last, this particular third observation. And let's go for fourth one. Parallel edges in graph produce identical columns and identical column and its incidence matrix. Parallel edges अगर होगी, तो 2 identical column generate होने वाली है. पक्का सोचिए क्यों ऐसा? Yes, there you are. Observe here, E1 and E6 both are parallel edges. Yes or no? E1 और E6 दोनों देखिए, ये E1 है, उसका end vertices AB, E6 का भी end vertices. तो अगर आप E1 और E6 की एंट्रीज देखेंगे ना मैट्रिक्स में, देखिए E1 और E6, पूरी कॉलम देखिए E1 वाली और पूरी कॉलम देखिए E6 वाली. Both these are identical. Both the entries in both these columns are identical. All the entries are identical. That is what I had mentioned in the last observation. Now, you ready with your pen? You are supposed to evaluate incidence matrix of the following graph. Here it is. Quickly. Giving you 3 minutes. All those who are attending this, I'm having 52 in the online mode and 6, 7 in front of me. So all of you will give me incidence matrix of this graph quickly. Giving you 3 minutes. I'm taking a small break. I'm going for water. Okay. Hello, now I'm here. Okay, hopefully you guys are done with this. Let me show you the incidence matrix related to this graph. This will be the incidence matrix. Now match this matrix with yours. All those who are in front of me. Let me check. Give me 2 minutes. Okay, I'm sure જે લોકો મારી સામે છે એ બધા તો વ્યવસ્થિત કરે છે. I'm not sure about you guys, those are attending this online. Hopefully you guys are also doing this. One more, quickly, one more. Take care. E is a isolated vertex. Take care. E is isolated vertex. Quickly. Give me the incidence matrix of this also. Try one more quickly. A, B, C, D, E, F. 6 vertices are there. We don't need the labeling of edges right now. I provided the labeling for the edges even, but we don't need we don't need that right now. You just need to go for adjacency matrix. Sorry, incidence matrix. It will be something like this: 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Yes, there we are. 6 number of rows represents 6 vertices. 7 columns represents all 7 edges. Is it? Let me use my pen. You may give labeling over there. This is related to vertex A, B, C, D, E, and F. Is it? E. Let me confirm. Yes, E is isolated vertex. So all the entries on the row related to E is 0. It reflects that E is isolated vertex, is it? And instead of using that notation 1, 2, 3, 4, 5, 6, 7, we should use, I think we should use E1, E2, E3. Sorry, you're not that much audible once again. Who's that?
Pema.
Yes, Pema, please. Continue, please.
No, sir.
Who's that?
Nothing, sir.
Okay.
I have mistakenly
Mute yourself. Good. Let me take you further. We are not going to waste our time for this even. Just go through it. देख लीजिए, ये भी समझ में आ जाएगा. बहुत simple सा है. Is it? A kind of similar stuff. Some of examples are there. Now, what we are supposed to do? Now let's apply the reverse. Let's apply this knowledge in the reverse way. Now I'm giving you a incidence matrix and you are supposed to draw a graph from this. Incidence matrix. Now take care. As I said in the previous example, when we are supposed to draw a graph from matrix, it should be clearly mentioned कि जो आपको matrix दिया हुआ है वो कौन सा है, whether it is adjacency matrix, क्या वो adjacency matrix है, क्या वो incidence matrix है. So clearly लिखा हुआ है, देखिए, it is clearly mentioned over there in the instruction. This is one of the incidence matrix, and you are supposed to draw a graph from this. So first thing you will do, that you will label your vertices, V1, V2, all of you will using the similar notation, V1, V2, V3, V4, V5. That will be the labeling of vertices, and for edges you will use E1, E2, E3, E4, E5, E6. देखिए गलती कहां पे हो सकती है. If you guys gonna give labeling over there as a vertex, अगर आप कॉलम में वर्टेक्स का नाम दे देंगे कि this is V1, V2, V3, V4, V5, V6, then it will create a mesh. अब ये गलत है, ठीक है. So this will be the graph with 5 vertices, 6 edges. Try to draw this graph. Nidhi Jain, are you there? Nidhi, are you there? Nidhi, Nikita.
Yes, sir.
सो गई क्या?
नहीं, sir.
Okay. Are you in position to share your screen with us? I'm giving you 2 minutes. Draw the graph related to this matrix, related to this incidence matrix, and then you are supposed to share your screen with us, with all of us. And I think 2 minutes is okay. Is it not, Nikita?
Yes, sir.
Okay, okay. Take your time. I'm giving you 2 minutes. All those who are in front of me, all those who are in front of me, I'm coming over to you. Chalo batao su peru. Okay, Nikita, let us know when you are ready.
Sir, I'm doing in book, मतलब rough में कर रही हूँ paper में.
Rough work is also okay. We are good with the rough work even.
Okay.
I just need to be sure whether you guys are doing this or not. So I'm picking some of the person randomly. You guys are waiting, huh, Nikita? It's fine. You may take your time, but it should not be like that कि तू बैठी है और हम लोग यहाँ पे wait कर रहे हैं.
No, sir, I'm doing just 1 minute.
Okay, okay.
Sir, may I?
Yes, please, Nikita.
Sir, can I share in camera or?
That will be your choice. Let me stop my screen sharing now. What you will do? Stay unmuted. Stay unmuted.
Yes, sir.
म्यूट मत कर देना. प्रेजेंट नाउ में जाके शेयर योर स्क्रीन कर, उसके बाद में कैमरा चालू कर दे, बुक के ऊपर रख, ठीक है?
Yes, sir.
Yes, Nikita, now start your camera. Not front one. Back side. Yes. There you are. There you are. Absolutely correct. Absolutely correct. Thank you. Thank you, Nikita. Stop your screen sharing. Yes, good, good, good. Is it? So one can easily identify it. It's very, very easy to identify. It's very, very easy to identify adjacency matrix as well as incidence matrix from the graph. Even the reverse process is very, very easy. But what we need to take care the things related to both the matrices, it must be clear in our mind. If whether we are dealing with the adjacency matrix, we are just supposed to deal with the vertices. If we are dealing with the incidence matrix, we are supposed to deal with the vertices as well as edges. Is it? So okay. Now we guys need to join in the second link, because then and then I will able to have one other video and which I need to upload for your attendance purpose. So I'm giving you 3 minutes. All of us will disjoin this particular meeting. यहाँ से बाहर निकलेंगे and we will be joining the next meeting which is available over your Google Calendar. Quickly यहाँ से निकलना है.